To start creating a GUI, the thing we have done is we have created a Windows Form app. So how do we do that? We go to File, New, Project, and then we select a Windows Form app. So this is the app, the C# app we will be creating. So as I've already created, I won't create it again. I just need to click it and then specify the name of my folder. So as this is done, so this is the form app that has been created. Now, like you can see, this is the initialized code. They have already provided with all the using statements we would need and the basic initialization of the form. So in the project name I put my GUI, so that's why this is the namespace. Now in the form, like I can change the form's name very easily by just writing here. So I will be writing my Robin so here I'll be naming it my Robin GUI. So like you can see, we have changed the label here. Now from the toolbox there are a few things that we need to add. So the back color, first of all I'll change the back color, active caption, and I'll just show you how this runs. So like you can see, this is what our GUI is going to look like. Getting back, now we'll be adding labels. For this we basically need 4 buttons in our entire GUI. Like you have seen, I have added forward, backward, left and right labels. Now I will be adding, using the toolbox, a text box which would basically instruct what to write. So the text should say enter the number of seconds for execution. So this is basically what the text would say. Now for color, let's change it to something, and I'll be changing the font as well. So I had changed the font to Cambria, so I'll continue with the same font. Font size 20, bold italic. So now this is basically what the text box looks like. And now we'll be adding checkbox. Now we need to add a text box that would take in values. Now for receiving values, I will basically add a text box. So this is a text box, and now we will go to the code. So when I double click, I straight away get to the code of text box 3. So what I need to write here is text box 3 dot text So with the code I wrote, if I show you how this is going to run, it has a text box, and if suppose I entered 3, so this text box has taken the value 3, and now the seconds variable is basically equal to 3. So now we will be copy pasting these labels. And now I'll be putting the same code into all these, because all these text box are doing is receiving the duration. So this duration has been received. Now we are supposed to get to the Arduino code. So in the text box change, I've initiated a variable seconds, and then the text which will be received in text box 3 is being converted into int32 value. So basically what we'll be doing is the seconds value we receive here, this is what we want to put into the Arduino, so that specific seconds, for those specific seconds, our robot will operate. Before that, we can add another button which basically would say go. It is like we are committing the function. So it says go, and let's just change it a little. It is supposed to have this color, and so this is the button. So now if the button is clicked, what we are basically going to do is that so likewise we will pass on values for the character. For text box 3, as it will help. It is the forward text box, like you can see this is text box 3. It moves forward. Text box 4 will move backward, hence the character we'll pass on is B. Then text box 5, which is left, so to text box 5 we'll be passing on L. And finally text box 6, which is right, so we will be passing on R. And like you can see, all this coincides with the Arduino code that we wrote. So now like you can see, we are passing on seconds. This is for text box 5, and similarly for text box 6. So we are taking the same value seconds, because at one time only one action will be performed, no matter how many boxes here would be fulfilled. Only one box has to return value at one time, and the course of action will continue. Well, we can make some changes, like seconds B for text box 4, and seconds F for text box 3, seconds L for text box 5, and seconds R for text box 6. So what this basically means is that we are having different values for each of them, and we will be reading them one by one. So first the forward motion will execute the number of seconds we have passed. For those many seconds it will move forward, then the backward will execute, then the left will execute, and then the right will execute. So this is how the code will basically work. Now, like you can see, there is some error with the port part. That is because we need to define a serial port. A very important using statement we need to add over here is of system IO ports, so that we can include the Arduino in our program. Now finally adding the most important line in our code, which is basically assigning the serial port. And as you could see in my Arduino IDE, by default my laptop would pick up the serial port COM8. So I will initialize the serial port, my port, and equalize it to a new serial port. So I'll create a new serial port object and I will pass on COM8 to it because that is what happens in my computer as default, and then I will be passing on the baud rate, which is 960, and the parity. So we have parity dot none right now, and then we have data bits. We'll be giving 8 data bits, and then we have stop bits dot 1. So as you can see, now we have defined our serial port. So now with the use of serial port, we will be giving all our values to the serial monitor in Arduino. Getting back to the Arduino code, I have used the same code I used in 7.1, as the functions for movement are the same, and the pins, right pin 1, right pin 2, left pin 1, left pin 2, and value, all these characteristics are the same, but I have made a few changes here. So a few more initializations have taken place. I have initialized a string named as input string, and I've initialized this as empty, and this is a string to hold the incoming data which will come from the COM port 8, through which we are connecting the Visual Basic GUI with the Arduino, and we will be transmitting this through Bluetooth. So the boolean string complete is equal to false initially. We will mark the string complete once a new line starts. So everything that occurs in a line would be considered as a complete string. Next is a string command string, which is initialized as empty. So this is also used for us to pass the COM port 8 statements. We are reading the values from the communication port. So next is setup. We have already set up the output pins. So this is what it looks like, and serial begin and the baud rate 9600, which is 9600, which is a begin. Then we have another string function, which is get string to print. So basically in this, the input string, the one which we received from the COM port, has a substring, and it will have, we'll read up to 5 characters, and then we will cut short the length by 2 units, and then we will return the value. So the value we are returning here. This value is what we're using in the if statements to tell whether to move forward, backward, left or right. So serial event. Now this is to check whether the serial is available, and so that we can pass on the values from the COM port, and then we initialize an in character which reads a value from the string, and we have casted it into character, and also after we cast it into a character, we further cast it into an integer known as sect. So this sect is basically what helps us define the duration for how much like we have to move left or right. So this is how serial event works. Now in the loop wherein it keeps on recurring, we have a while loop which says that if cereal is available, we will read the value from the serial and we will also print the value from the serial so that we know what values are being processed. So then we have an if command string, and if it equals to text, then the string text, the one which we get as a parameter, we will get that text into printing so that we know what is being processed in our program. After that, we initialize input string again as empty. Now, the few if statements that we have here, which help us define what happens when. So if the value is equivalent to f's, if we have a value returned as f, then the right pin will be low and the left pin will be high. So if left pin 1 is high and right pin 2 is high, then our chassis will move forward, and this will happen till the time delay second, like you have seen in the Visual Studio code. We built the GUI and we asked for the seconds. So like if suppose I say that I want 6 seconds forward, if I put 6 in that blank, then 6 multiplied by 100 microseconds. So basically that means that we will move 6 seconds forward. So this is basically the delay, and this is where our variable second comes into use. So likewise we have the left, wherein if digital pin are high or low, we define which direction it has to move. So now we are getting the command. So this is if our string input, this is a void basically, through which we get our values from the Visual Basic GUI we made into the Arduino. And like you can see, the input string dot substring, so up to 5 characters we will be reading in this as well. So this is basically how the Arduino code works. Like you can see, it is pretty simple. So I'll be getting back to the Visual Studio Code, wherein we have the serial port. Now, as my serial port defined in the Arduino is a COM8, so here we check if Arduino is connected. So we only perform activities if Arduino is connected. Now I'll be working on a little more on this code. So like you can see here, I will only be performing activities if is connected variable is equal to true. That is, we will only save the values for seconds or other things if we have the serial port connected. So like you can see, so this is basically repetitive code, so I'll be just copy pasting it everywhere else, and I'll just be changing the text box variables, because different text box will get different values. Also button 1 which says go will read the value from text box 1 and so on. So like you can see, we are making it read all the values such that it can return. Also, we will be making it return like you can see here, wherever we are passing on seconds, we will also pass a character. So is text box 1 is basically for moving forward. So character, let's say my character. So as text box 3 is for the case of forward, we will be replying with F, because we know that F is the variable which needs to be passed on in the Arduino code for it to move forward. Casting won't work, so we are converting it into character. So this is how we will be getting the character values which we will be passing on into the Arduino, so that we can get our chassis moving forward, backward and so on. So let me just check. So now, like you can see, I will be connecting this wire along with the battery pack, and I'll be sticking the battery pack over here at the end of the system. So this is the final connection for the battery pack. Now in the motor, like you can see, in the motor driver, like you can see, I have already connected the in 1, in 2, in 3, in 4, in 5 and so on pins, along with the ENA and ENB. So now these connections are to be further connected with the Arduino, and these two wires coming out of here, this one is for VCC and this one is for ground. This also we will be connecting to the Arduino. Now like you can see, I have made the Arduino connections. These two wires are free, which are for EN1 and ENB and ENA. So I'll be using these two female wires to short these pins so that we can get the full potential running through the DC motors, so we get the full speed of the motors. Now that I have put the wires together using sellotape and attached the Arduino to the chassis, all that is supposed to be done now is using the COM port wire and connecting Arduino to the laptop. I'll be using an extension so that our chassis can move more freely, because the wire provided with Arduino is very short. So this is the extension, and this I'll be connecting to my laptop, after which I will start operating the GUI. And this is supposed to be connected to the Arduino. put the right pin 2 at 5 and left pin 1 at 10, which are basically PWM pins. So I changed the connections in the Arduino board as well, and then I made further changes. I went to processing part, wherein forward I change all the low references to 0 and the higher references to only 40. So this can be done by going to edit, then I went to find, then I found out all the references for low, that I changed into 0, replace all, and then I found all the high references and I changed them to 40, replace all. After this, I changed the digital write into analog write. And this was all that was required to get my chassis slowed down and move accordingly. Like you can see, we have this GUI wherein I will put the numbers 4, 3 seconds for backward, and let's keep 2 and 2 for right. So it moves forward for 4 seconds, backward for 3 seconds, left for 2 seconds, and then right also for 2 seconds.